Hi, in this video I'm going to demo the group assignment task question F on how to conduct or perform the analysis for hypothesis testing of relationship between three or more ratio variable. For this part, you have to create the equation, multiple regression equation, and to test whether each of the factors are significant factor. Make sure you choose the variable for RQ relationship between one ratio variable with two or three other ratio variable depend on your RQ. And let's say for this example, it is one ratio as the Y and another two ratio as the X. If you have three X, then it will be three factors. First, this is your data. This is the data. And you have to define each of the data. If you have three factors, then it will be X3. Let us begin with the analysis. By using Excel, you go to data, data analysis, and regression. For the input, for Y range, you select the Y, the whole Y. And for X range, you select the whole X. If you have three X, then it will be the whole three column, the three column of the data. If you have two X, then it will be two column of data. Click on the label. For output range, you select where you want your output to be. And then that's it. You can press OK. Excel will provide this output. What you have or what you need is the coefficient of intercept and the X. From the coefficient, you can create the equation of multiple regression. You also will need the p-value here and the test statistic here to perform the 5-step hypothesis testing to test each of the X here, whether they are a significant factor to the equation or to the Y. How to do that? In your PDF file, make sure you define your variable, put in your output, and perform the 5-step hypothesis testing to test each of the predictor or the X. So for if you have 3X, you will have 3 set of hypothesis testing. Okay, step 1. Beta equals to 0 means predictor is not significant. H0, H1 is beta not equals to 0 means predictor is significant. We will use the p-value method. Step 2, you just put in the test statistic value. Okay, not this one actually. Okay, you have to refer to the t-stat given for each of the predictor. Okay, and this one will be, for this example, it is 19.6. 19.6051. Step 3, the alpha, the p-value. Okay, the p-value, you have to look at the output also. 1.09 times 10 to the power of negative 35. And then step 4, you do your decision whether to reject or not H0. And step 5, you have to conclude whether predictor is significant or not. Same goes to here. For x2, step 1 still h0 and h1 is beta equals to 0 is predictor is not significant. Beta not equals to 0 is predictor is significant. Best statistic value, you have to refer to the second predictor, which is negative 8.24852 for this example. For this example. And step 3, put in the test statistic, put in the p-value. Okay, you have to refer to the correct p-value, which is this one. This one. And do your decision and make your conclusion. So for this case, both are significant, then the equation still become the same. If not significant, then it will change. Okay, that's how you do for F. Thank you.